Here's problem 2816. For the figure shown, if the EMF of the battery is 18 volts, what joule heat is produced in the 10 ohm resistor in 5 seconds? Alright, so if we're thinking of trying to find the heat produced, we know that power is energy per time, the rate of energy per time. And so energy will equal power times time. So if we could find the power in that 10 ohm resistor, multiply it by the time, we would get the joule heat produced by that resistor. Okay, to do this, let's simplify the circuit a little bit. We've got this parallel combination of a 10 with a 15. Our parallel would be product over the sum. 15 times 10 over 15 plus 10, which would be 150 over 25, which would be 6 ohms. So now our circuit looks like this. We have 6 ohms over here, 12 ohms on the bottom, and then we have a 18 volt battery. Okay, if we did this series combination of the 6 with the 12, our R equivalent will then be 6 plus 12, or 18 ohms. So that is our R equivalent for this circuit. Hence, the current coming out of the battery is going to be the voltage of the battery divided by our R equivalent. 18 volts divided by 18 ohms, 1 amp, coming out of the battery in any representation we choose. So in this last representation, we truly have 1 amp that's going through this 6 ohm resistance. And hence the voltage across that 6 ohms is going to equal, by Ohm's law, I times R, 1 amp times 6 ohms, or 6 volts. So there's 6 volts across that 6 ohms. But that 6 ohms represents a parallel combination of the 15 with the 10. So there also is 6 volts across that parallel combination, because things in parallel have the same voltage and have the same voltage as their equivalent device. So the voltage of the 10 ohms will be equal to the voltage of the 6 ohms, which would be equal to 6 volts. That means, well, we can find the power in the 10 ohms. The power in that 10 ohms will be the voltage squared divided by resistance. 6 volts squared divided by 10 ohms will be 36 divided by 10, or 3.6 joules per second, or watts. So we have a power of 3.6 joules per second generated in that 10 ohm resistor, and the energy generated in that resistor would be power times time. So that would be 3.6 joules per second times 5 seconds. So that will give us 18 joules. So we'll have 18 joules of joule heat produced in the 10 ohm resistor in 5 seconds. That's our answer, 18 joules.